Hi again and welcome to Artificial Intelligence and Machine Learning Foundations course. In this lesson, you'll learn the basics of Python programming such as data types, variable declarations, type conversion, operator, conditions and loops, and functions. I'll show you how to install two of the most commonly used IDEs when working with machine learning projects in Python, Jupyter Notebook and Pycharm. So if you're new to Python and wants to jumpstart your skills in Python programming in 30 minutes, then this lesson is for you. So before anything else, what is Python and why do you need to learn this language? Well, Python is an interpreted, object-oriented, high-level programming language with dynamic semantics. Aside from the fact that this is one of the most easiest programming language to learn, Python developers are very in demand. The current trends in programming languages show that Python sits at the top spot as the most wanted programming language in 2021. Python's popularity is perhaps attributed due to its versatility. It has so many use cases in different fields, which include data science, statistical computing, data visualization, machine learning and artificial intelligence, web scraping, data engineering, process automation, IoT, game dev, desktop app, and web development. Just to give you an idea, some of the most popular websites and platforms that are built with the help of Python include Google, Pinterest, Netflix, Spotify, Dropbox, and Instagram. So with that being said, let's get started. I'll show you two ways on how you can start writing your code in Python. First option is to download and install the latest version of Python separately from python.org. When installing, you may want to click this checkbox that says Add Python to Path. Once finished, you can then download and install your preferred IDE, or you can use any code editor that you prefer, like VS Code or Sublime Text, and it will work great with Python. However, when working with machine learning projects, several IDEs excel as compared with others, one of which is Pycharm. Pycharm is an IDE developed by JetBrains and created specifically for Python. It is perfect for those who already have experience using another JetBrains IDE like IntelliJ IDEA. Pycharm is particularly useful in machine learning because it supports libraries such as Pandas, Matplotlib, scikit-learn, NumPy, and so on. In addition to Python, Pycharm provides support for JavaScript, HTML, CSS, AngularJS, Node.js, and so on, which makes it a good option for web development. So, to install it, go to jetbrains.com/pycharm/download and download the free and open source community edition. Run the installer and follow the step-by-step installation process until it's done. The installation process is fairly straightforward. I'll check this to run the Pycharm IDE automatically when finished. I'll accept the terms and conditions to continue. To create a new project, simply click this plus icon. I'll accept the default configuration and click Create. Our new Python project is ready, and it shows a default file, main.py, containing a sample Python script. I'll delete this sample code and start writing our own to demonstrate how easy it is to write Python codes. To display something on the screen, you simply call the built-in function print and print anything on the screen. To run the code, simply click this play button or press Shift plus F10 and you can see the output message that says Hello Python showing at the bottom portion of your IDE. To receive an input from the user and store it in a variable, you can use another built-in function, input. You can pass any string message to this function for the user to see. This input function reads a line from the input, converts the line to a string, and then returns it. In this case, we store the input string in this variable name.
To test if we were able to successfully receive an input string, I'll call the print function again and say hi, followed by the plus operator, and then the variable name, and then the plus operator again, followed by the text, "Welcome to Python Programming." When I run this code, the output displays a message, "Hello Python," and "What is your name?" The input function is waiting for a new line, so I'll type in Joed and press enter. And the resulting message is, "Hi Joed, welcome to Python Programming." If you've written codes using any programming languages before, you can instantly see and compare the simplicity of Python. Like with Java and C, for example, Python code is much cleaner to look at. That is why it is a commonly used language for beginners. If you are working on Windows, you can launch the command prompt and then type Python. You can see the current version of Python installed on your machine, and from this command line, you can start writing your Python script. So let's try the same code that we did when we used the Pycharm IDE. I'll print "Hello World," then ask the user to enter the name. Finally, I'll display a message, "Hi," plus name, "Welcome to Python Programming." Another option to start working with Python is that if you're a beginner in Python and data science, you might want to consider Jupyter Notebook. It is a web application based on the server-client structure that provides you with an easy-to-use, interactive data science environment across many programming languages that doesn't only work as an IDE, but also as a presentation and education tool. It is great for prototyping and sharing notebooks with visualization. And to install Python and Jupyter Notebook along with the other data science packages all in one, without you worrying how to install individual packages, then go to the anaconda.com/products/individual. At the bottom part of the page, you'll see the different versions of Anaconda installers for Windows, Mac OS, and Linux. Go ahead and download the installer that suits your operating system. Mine, I'll download the 64-bit graphical installer for Windows. Once done, launch the installer and simply follow the step-by-step installation process. Similarly, this is fairly straightforward. And once finished, you can now launch the Jupyter Notebook, or you can launch the Anaconda Navigator and see the different applications that you can work with. From here, you can launch Pycharm, Spider, or VS Code to start with your Python project, or this Jupyter Notebook IDE. Another option to start your Jupyter Notebook is through the Anaconda command prompt. In here, you simply type Jupyter Notebook and then press enter. This runs the notebook server locally and automatically launches your web browser. So, to create a new notebook, click New, Python 3. This opens a new notebook document and you can start writing your Python scripts. Normally, you would want to give your notebook document a title. So just click this Untitled and give it a new name, say Sample Code 01. In Jupyter Notebook, this is what we called a cell. It has two basic colors, blue and green, depending on whether the cell is selected but not in edit mode, which is blue, or green, which indicates the cell is active for editing. I'll type the same code as I did in Pycharm and in the command line. So to run it, you can simply click this play button that says Run Cell, select below. Or you can click the cell menu for more options. When writing your Python script using Jupyter Notebook, you can break your codes into several cells as you desire. You can use these very useful keyboard shortcuts such as Ctrl+Enter to run cells, or Shift-Enter to run cells and then select the next cell below, or you can run all cells. Since I only have one cell here, I'll choose this and you can see the output of the code right away after the cell. Then, it creates a new cell below it and selects it. Using this approach, I can continue writing my Python code and when I press Shift-Enter, it executes the code. I can type my name, and when I press the Enter key, it prints a message, "Hi Joe Edgo, welcome to Python Quick Start." You can always go back to any cells and modify your code. Then, press Shift-Enter again to run the cell and select the cell below. When a cell is selected but not in edit mode, it has a left border color blue. You can click anywhere inside the cell or just hit Enter key to go into edit mode. To go back in command mode, simply press the Escape key. Then, you can use the arrow key to navigate up and down between cells. By default, you use cell to write Python code. But you can also change the cell type to Markdown. A Markdown cell can contain any text documents or notes formatted using Markdown language. This allows you to create and share documents that contain live code with equations, visualizations, and narrative text. You may want to improve your Markdown writing skills if you want to present your work in Jupyter Notebook with enough explanation to your reader about your code and the concept. But I will not be elaborating on this part, so we can proceed with learning the basics of Python. You can also edit your cells to move it up or down. You can delete a cell using a keyboard shortcut by pressing the D character twice. Make sure to press the Escape key first so that your cell is in command mode. You can also use this toolbar to rearrange the position of your cells. You can also paste, copy, cut, or insert new cells using this toolbar. A very handy keyboard shortcut to insert cells above, simply press A. Or to insert a cell below, simply press B. Again, make sure that you are in command mode when you do this. Now, there are plenty of other keyboard shortcuts that you might find useful. Just check it under the Help menu. Your notebook document is autosave every 120 seconds by default, but you can save it manually if you want. So now, your Jupyter Notebook file is saved with an extension name of IPYNB, which stands for Interactive Python Notebook. And if you want a Python file, just click the File menu, Download As, and select Python. If you close this tab, this doesn't stop the running notebook. So, to stop it from running, select the file and click Shutdown. To start it again, just click the file that you want, and a new tab will open for your running notebook. I have created a new folder in this current directory called Notebook Files. I'll select it in my Jupyter IDE, and inside this folder, I'll create a new notebook. Program 01. Using the print function, you can basically print anything here. And using an input function, you can also enter anything here. And as simple as that, I can use the print function again to print a new message together with the input value stored in this variable x. I'll test it. And it works perfectly. So let's talk about data types in Python. You can use the type function to determine the type of the data you're currently working on. Say I'll pass in this text, Joe Edgo, enclosed in double quotes, and when I run, it gives me an output of type str. This denotes a string data type. I'll call the type function again and pass in 123. It returns int. Now I'll pass 123.456 and the return type is float. And lastly, I'll pass in true with capital T, and this gives me a bool data type. So when writing code in Python, there are only 4 basic or simple types to work with. We have string, int, float, and bool. And when you use a variable in Python, you don't have to declare or specify its type. Now, don't think that Python is a weakly typed language because it's not. Python is a strongly typed but dynamically typed language. Dynamic typing means that the type of the variable is determined the moment you first assign a value to it during runtime. And strong typing means that variables do have a type and that the type matters when performing operations on a variable. So you cannot just simply add 2 variables with one being of type string and the other one of type int. It will throw an error. You'll see similar behavior with other strongly typed languages like C# and Java. Consider this sample code. I'll accept an input and store it to variable age. Then, perform a simple addition by incrementing its value by 1. Then, I'll print a message that says, next year, you will be, and then use the same plus operator to display the age. When I run the program, it asks me to enter my age. I'll type 28, and when I press enter, it throws an error. It points to this second line of code with an error message of, it can only concatenate string, not int, to string. So this error is triggered by this. The input function returns a string type regardless of the character you type from the keyboard. And this determines the type of our age variable dynamically during runtime. Now, as we perform an arithmetic operation to this variable age by adding an integer value of 1, Python won't allow it. It expects that since age is a string, when you use a plus operator, it expects that you are going to concatenate it with another string. Thus, it throws an error. So, same with other strongly typed languages, Python offers a number of functions that convert one type to another. By the way, a $sign is used to denote a comment in Python. Anything after this symbol will not be executed. Now, since I don't want to just concatenate 2 strings, but instead I want to perform an arithmetic addition, I'll convert this age variable to an integer type using the int function before adding a value of 1 to it. Now, because Python is a dynamically typed language, the type of the variables can be changed during program execution, even after they have been set. And this behavior is different from other statically typed languages like Java, C, or C++, where the variable type must be known during compile time and cannot be changed. Let me run this. And when I enter 28, another error message appears, pointing to line 3, and it says the same error message. Now, this happens because age variable has been changed to a new type of type int when we assign a new value to it in line 2. It is no longer a string. So, as you can see, dynamic typing allows your code to be flexible, but it comes with a price. So, to resolve this, I'll use another function, str, to return a string value of age before concatenating it with another string. I'll test it again, and it works perfectly. You can use other functions aside from str and int to convert one type to another. You can use float and bool functions as well. So let's have a simple demonstration for each of these types of functions. I'll create a program that asks for a patient name. This is expected to be of type string. Then, age. I want it to be of type int, so I can call the int function right away after accepting the input string. Then, temp for the temperature, and I want it to be converted to type float. And lastly, COVID check of type boolean to either be positive, which is true, or negative, which is false. Now, let's print back the following information to the screen for confirmation. I'll print name, concatenated with the input patient name, then age, concatenated with the string value of age. I'll do the same for temperature and for COVID check variables. I'll run it and give some values. And it looks good, except for this COVID check value. I typed false, but it prints true. Well, actually, when using the bool function, anything you type here as a string will be converted as true in Boolean. So, how do we resolve this? If you are just accepting this as either the word true or false, then just accept it as a string and print it back as a string. This simplifies the operation. But if you're going to use this as an actual Boolean type so that you can use it for a specific purpose in your code, like in a conditional statement, then you need to convert it first to an integer before converting it to Boolean. 0 means false, and any number other than 0 is true. And then, just make sure to convert it to string before concatenating it. So now, if I type 0, it is successfully converted to false. And if I type 1, it is converted to true. When working with strings in Python, you can represent it in several ways. First is by enclosing any text in double quotes. You can also represent a string enclosed in a single quotation mark. You can also use triple quotation marks to represent a string. So, what's the difference? You might want to use a double quotation mark if you will be using an apostrophe inside your text, like it's a sunny day. You would want to use a single quotation mark in scenarios where you want to include double quotes in your string value. And finally, you'll use triple quotation marks if your string value contains single or double quotation marks. When working with strings in Python, you must also know that it is an immutable object and it has several methods in it that you can use. Immutable means once content has been created in the memory, it cannot be changed. So, in effect, reassigning a new value to your string variable creates a new string in memory. Let's explore some of the useful string methods. So, the term function is the same as method. But when you pertain to an object like a string, we use the term method instead of function. And in Jupyter Notebook, if you want to display the list of all the members like methods associated with an object, just press tab after the dot operator. For example, the upper method returns a string value where all characters are in uppercase. The lower method returns a string value where all characters are in lowercase. Note that these methods are non-destructive. It doesn't change the actual value of the original string contained in a variable. Now, let's try the find method. To display a method signature so that we can see what parameters a certain method is expecting and its return value, just press Shift-Tab. So, according to this, the find method returns the lowest index in a string where a substring is found. So, let's check. I'll pass in P, and it returns 15, meaning the character P is positioned at index 15. This is the 16th character in this array of characters. I'll try another one. I'll pass in a small letter q, and it returns -1, which means not found. I'll change it to capital letter Q, and it is found at index 0. Now let's try to find a word, start, and its starting position is at index 6. Great. You can also use the replace function, and I'll pass in two arguments. First is the substring you are looking for. The second is the replacement string once found. Now, aside from the find method, You can also use the special keyword in that checks whether a certain string value is found in another string. But instead of getting an index number, it returns a Boolean value of either true or false. In this case, the string Python is found, so it returns true. I'll try to look for a different word, say anaconda, and it returns false. So let me just insert a markdown cell here that says working with strings in Python. Now let's check the different operators used in Python. You can use the common arithmetic operators like plus to add, minus to subtract, and asterisk to multiply. But when you use two asterisk symbol, this means raised to the power. So 5 times 5 is 25. And 5 raised to the third power is 5 times 5 times 5, which is equal to 125. You can also use forward slash to perform floating point division. But when you use double forward slash, it means integer division. When you use arithmetic operations to a variable and eventually use the same variable to store the final result, you can simplify this using compound operators like this. You can apply the same concept for subtraction, multiplication, and division. When performing arithmetic operations, take note of the operator precedence. In this example, number variable has a computed value of 11 because 3 times 2 is evaluated first before adding 5. And if we want to prioritize 5 plus 3, we simply enclose this in a parenthesis and this gives us 16. I'll change this markdown and say arithmetic operators. Now let's talk about relational operators in Python, where we can compare two values and it returns a Boolean value of whether it is true or false. So 2 greater than 3, which is false, 3 less than or equal to 5, which is true, 3 is equal to 3, which is true, and 4 not equal to 4, which is false. So relational operators in Python are greater than, less than, greater than equal, less than equal, not equal, and equal to. And then the logical operators are and, or, and not. Say, using a relational operator to compare if a score is greater than or equal to 70, this gives us true. We can combine the results of this first comparison with a second comparison using a logical AND, so that it will only be true if both comparisons yield true. Otherwise, it will be false. Say, I set the value of score to 86, which makes the entire expression to be evaluated as false. However, changing this to logical OR requires only one of the two Boolean values to be true for the entire expression to be evaluated as true. Both comparisons must be false for the entire expression to be evaluated as false. And of course, using the logical NOT reverses the Boolean logic value. Now, you can best appreciate relational and logical operators when working with conditional statements. In Python, you can use the keyword if followed by a condition and then a colon. And sure, this code prints a string passed because the current value of score, which is 86, is greater than or equal to 70. You can put multiple statements inside an if block and it is simply denoted by an indentation. So if you've been using C-related programming languages, you are definitely used to using curly braces to enclose the entire statements inside an if block. Well, this is not the case in Python. I'll modify this so that it accepts input from the user. If I type 80, it says pass, congratulations. However, if I try 67, it doesn't display anything. Now, I'll add another print statement here but this one will not be part of the if code block since I removed the indentation. In effect, the string thanks will be printed regardless of whether the condition in the if statement is satisfied or not. If you want something to be performed when the if condition is evaluated as false, you can use the else. And you can write any statement under this else block as long as these statements are indented. Let's run and try it again. And it works perfectly. So in addition to the if statement with an optional else block, you can test for multiple conditions once the if condition is not satisfied. You can insert optional elif blocks and provide another condition to be tested. So this elif condition gets tested only if the score is not greater than or equal to 70, meaning below 70. And having a condition of elif score greater than 65, this means that the elif code block will only be performed if the score is above 65 but below 70. So if I type 70, the if condition is satisfied and the if block is executed. And if I type a score of 65, the if and the elif conditions are not satisfied, then it goes to the else block. And lastly, if I type a score of 67, the if condition is not satisfied, but the elif condition is, and its code gets executed. Note that you can have as many elif conditions as you wish. There are two types of looping statements in Python, the for loop and the while loop. Let's start with the for loop. The easiest way to use a for loop is with the use of the range function. The range function returns a sequence of numbers starting from 0 by default and ends before a specified number, with each sequence incremented by 1 by default. So when we say for I in range 5, this means that I will have a value starting from 0 up to 4, and for every iteration or loop, I gets a new value from the range function that is incremented by 1. So if you want, you can create a separate variable that holds a range of numbers and then use that variable in a for loop instead. So this will perform exactly the same. Note that you can also pass in 3 arguments to this range function to change its default behavior. First argument is the starting value. The second is the stop value. And the third is the step or the increment value. I'll print each value of I. Then I'll run it and it works great. I started with 5 and incremented with 3 after every loop until it reaches 19. Again, the stop value, which is 20, is not included in the range. You can also loop through any string and get each character starting from the first character up to the last and assign it to variable I after every iteration. Now, the other type of looping statement in Python is the while loop. To achieve looping using the while construct requires an extra line of code as compared with the for loop. You need to assign an initial value for your looping variable. Then, use a condition that while it is evaluated as true, the code block will be executed. And the most important thing is to put an increment or decrement operation to alter the value of your looping variable, so that the while condition will eventually be evaluated as false to exit the loop. Otherwise, if the while condition is always true, then it will never get out of the loop, which makes your loop infinite. Although you cannot use the plus operator when adding or concatenating different types such as string and integer, but when you use a multiplication symbol asterisk for both number and string, this is a valid operation. It means multiply a string a number of times. Our last topic is function. To start organizing your Python code into smaller code blocks, consider this sample code. Suppose we want the user to input a score from 1 to 20, Then, we compute its grade percentage by dividing the input score with 20 multiplied by 100. We'll print the computed grade, and then check whether the grade is greater than or equal to 70. If it is, we'll print a message you passed, otherwise, print you failed. Let's test it. Say the score is 17, your grade is 85, you passed. Let's test it again. Say score is 12, your grade is 60, you failed. Now, we create functions so that we can reuse certain lines of code in a block anytime we want by just simply calling the function name. And suppose we want to place this congratulatory message in a separate code block. And to do that, I'll insert a new cell above and define a function with the name congrats using this keyword def. A function name must have a pair of parentheses at the end, then a colon to denote the start of the indented code block. So this function consists of two print statements. And in here, I'll simply call congrats. Now let's test it. And it works same as before. This is the simplest type of function, no parameter and no return value. Now let's define a similar function, sorry, and print some sorry messages inside this code block. Now make sure to run the function first before you can use it anywhere, because if you don't, you'll get an error message similar to this. Function is not defined. So, I'll run it first, then test it again, and it works great. Now let's define another function that returns something to the calling program. I'll cut this code and assign the input score to a local variable s, and then return it to the one who will call this getScore function. So in our calling program, I'll simply call getScore, and this function will do the task for me. Let's test it again, and it works same as before. Now, let's create another function that accepts something from the calling program and then returns something as well. Say a function that computes for the grade. It has one parameter, score, then it uses this score to compute for the grade, which is stored in variable g. And finally, I'll return this computed grade g to the calling program. So in the calling program, I'll simply call compute grade and then pass in a score, and in return, I am expecting a computed grade. So let's try this, and it works as expected. Finally, I'll define one last function that prints the grade and its associated message. I'll cut this code and insert another cell above. This function accepts grade as an argument, but it doesn't return anything to the calling program. So, in the calling program, I'll simply call the displayGrade function and then pass in the computed grade. So, let's test it one last time with different set of input values. And it works perfectly.
Up next, you'll learn the different built-in data structures in Python so that you can improve your productivity in writing your Python codes. And again, thank you very much for watching. And if you learned something of value here, please click the like and subscribe button for more programming tutorials. This is Joe Edgo, and hope to see you again in the next lesson.